Swayam Prabha. Digital India. Educated India.
So, last class I have discussed that how we can determine the HU value for fixed headed pile in cohesionless soil, and I have discussed two cases, short pile and the intermediate piles, and this is the short pile. So, these are the two equations by which we can determine the HU and the maximum moment, and in this case maximum moment will be at the surface, and this is the condition by which we can determine what is the maximum lateral load capacity of the pile, and we can determine the mx also, which will act at a depth of f, and then as we know that the f equation we can determine, because f expression is already given. So, what is the f expression? F expression was given in previous classes. So, that f expression is which is for free headed pile part, that f expression is given, and f is equal to 0.82 root over HU by d k p gamma or gamma dash. Okay. So, how we are getting that? Because f expression we are getting by equating this equation, because it is we are taking or we are taking this value here, because that we did for the free headed pile. So, this is nothing but 3 gamma dash d k p into f. Okay. So, that force will be equal to H u. So, that H u is equal to half into 3 gamma dash d k p f into f. So, here we can write that f is nothing but 0.82 root over H u gamma dash d k p, or this is the value. So, by using these equation I can determine, because once I get the H u by equation 2, then I can put this H u in this equation 3, I will get the f. Now, once I know the f, now with respect to this f point I can calculate the m max, what is m max, and then I will check whether it is less than m y or not. If it is less than m y, then fine, intermediate pile, otherwise it is a long pile. So, now I will go to the long pile case. So, for the long pile, fixed headed long pile case, that this is the ground surface. Okay. And this is the fixity of the pile, and this is the pile, which is the long pile, and in case of long pile they will be yielding at a point. Okay. And this is the say pile cap, this is L, and this distance is where the yielding occurs is at a distance of f, and then the soil reaction. So, again this will be something like that. Okay. And this is the value, which is 3 gamma dash d k p into f. because this is F, and this value is basically at F, where the maximum bending moment also will occur at F, and now there will be a moment, yield moment at the surface as well as at the point F. So, this is the maximum yield moment. So, I should write this is the point, yes. Fine. So, this is the bending moment diagram. Okay. So, this will be m y, because it is a long pile, and this is also m max, which is equal to m y, and this is acting at a depth of f. So, this is the deflection, this is the soil reaction, and this is the bending moment. Okay. This is max. So, this is bending moment, this is the deflection, and this is soil reaction. Okay. So, these are the different diagrams. So, here also I have drawn the all the cases. So, now for the fixed set case, what are the values? So, I should write that I have to calculate the HU, and there will be a yield moment m y. Okay, because there will be a yield moment m y in this fixed set case. And then now for the fixed set case, a max at the point F definitely will be equal to m y. Okay. Now, we are taking the moment m y at a distance of F from the surface. So, taking moment at a distance F from the surface. So, HU is now it is at a distance of F, and that point the m, this m is nothing but m y. So, m y at that point will be equal to HU into F. Okay. Then the negative contribution, and again we assume that up to F point this is the linear portion, and that point is total force will be half into 3 gamma dash d k p F into F, and we are taking from this point F. So, this is the, if I consider it is a triangle above the F point, So, then this will be F by 3, then there will be a moment m y is acting at the surface. So, minus m y. So, this is the with respect to F point. So, this is the moment with respect to F point, and that is also yield moment. So, we can write that this will be 2 m y will be equal to F u h u into F minus. So, this is nothing but F. So, that I have already discussed that this is nothing but F h u, this portion is nothing but h u. So, this is also 3 by 2 gamma dash d k p f square, this is also 3 by 2 gamma dash d k p f square, this is equal to h u. So, this will be h u into F divided by 3. Okay. So, this will be 2/3 HU F. So, I can write that 2/3 HU F will be equal to 2 my, or I can write HU will be equal to 3 my divided by F, and where my is again known. Okay. So, now how I will get the f value? Again f value is equal to the same expression, because here also we assume this is the linear above the f point, soil reaction is linear. So, again f will be equal to 0.82 root over HU d Kp gamma dash. So, this equation 1 will give us the HU, equation 2 also give us the F value. So, we have two unknowns, F is one unknown, HU is another unknown, and we have two equations. So, we will solve and we will get the HU, and the maximum moment is now the yield moment. So, that is known. So, this way we can determine the HU and the position of maximum moment for long pile. And so, that means here also I have derived for questionless soil, I have discussed the equations for the 5 cases, what are the possible equations. So, either you can use those equations, and based on those equations again the charts are given. So, you can use these charts also. So, that means for the fixed headed pile, this is the dotted line, farm headed free headed pile, farm lines are there, L by D again less than equal to 20, then I will get HU Kp d cube gamma dash. Okay. So, this is HU is divided by Kp d cube gamma dash. Here also we should know the Kd value, Kd this is not the Kd, this is the Kp. Okay. So, Kp d to the power 4. So, here also I will get HU Kp d cube gamma dash, and this is the this dotted line is the fixed headed pile, and farm headed pile, this is the farm line. So, this is 0 is this one. So, 0, 1, 2, 4, 8, 16, 32 for free headed pile, and fixed headed pile, this is dotted line. So, either you can use this chart or the equations. So, this way we can determine the ultimate load carrying lateral load carrying capacity of piles and the moments and the positions of the maximum moment by using Brom's approach. Then I will discuss another approach which is called the simplified approach. So, in this simplified approach, which is very I mean obviously it is simplified means is very simple. What is that approach? And that is for free headed pile. So, that simplified approach, suppose this is a free headed pile, this pile is subjected to a lateral load HU with a eccentricity E. So, there will be a moment also which is MU, which is nothing but HU into E. So, it is assumed that this simplified approach, then this pile will definitely rotate, because it is a free headed pile. So, it will rotate like this. So, upper portion there will be a passive resistance, a lower portion there will be a passive resistance. So, that means here the distribution is something like that. So, is this point there will be a change of the distribution. So, this is the distribution, and for that this is the distribution. So, only this distribution is assumed, and that is it. So, based on that we will calculate what would be the ultimate load carrying capacity of the pile. How we will calculate by this distribution? I am showing one particular case, that HU will be equal to this net reaction. Okay. So, that net reaction, suppose this is the Z r, where the z r is the point of rotation, where the soil distribution changes from this passive resistance in the upper portion or the within the z r portion, it is acting from right to left, and below it is acting from left to right. This is the this passive resistance. So, we can write that this is equal to 0 to z r integration p u d dz, and then minus, because this is in opposite direction, it is z r to L p u d z dz. Okay. And similarly, I can write that mu maximum moment into E, that is equal to, because now moment we are taking in the opposite sign. So, it will be minus, or I can take this is first. So, z r L, this will be p u d z dz minus 0 to z r p u d z dz. Okay. Now, what is p u? P u is the soil pressure, and it varies from p 0 to some value. So, that means, here at p u is the soil pressure at any depth. So, p u is equal to p 0 at z equal to 0, and p u is equal to p L at z equal to L. So, this is basically at any point, this is p u, which is soil pressure, and then that this unit is kilonewton per meter square, and if I multiply with d, it will be kilonewton per meter. That we are doing for all the cases. Now, this p u distribution, as I have discussed already, that for cohesive soil, this p u is equal to p L, that means uniform, or you can write p 0 also, that means it is uniform. Okay. But for cohesionless soil, this is not uniform, this is varying linearly. Assume it is varying linearly from p 0 to p L. Okay. So, p u varies linearly from p 0 to p L. So, p 0 means at z equal to 0, and this is z equal to L. So, it is varying, p u is varying linearly with p L, and so that means it is if p 0 is equal to 0, then the variation will be something like this. Okay. This is p L. So, in such case, p u will be the average pressure, because this is 0. Now, p u will be equal to half p L. So, in that case, if this is z equal to 0, that is z equal to L. So, now for uniform case, so that means for uniform case, the distribution of the pressure will be something like this. This is the point of rotation, the distribution will be like this. It is not in scale definitely. So, this will be the distribution for uniform case, and this is always p u, this is also p u. Okay. So, for this, I should write that for uniform case, how we can calculate the HU expression? So, we can calculate the HU will be equal to that this is ZR. Okay. So, this will be your PU and you are multiply D into ZR, okay. Then minus PU into D into L minus ZR. So, that is the total net reaction and that is equal to HU. So, that means we have L minus ZR. So, finally, I will get a expression in terms of HU divided by PU dl. So, that is equal to 2 ZR by L minus 1. So, this way if I know the ZR and if I know the ZR, the point of rotation, then I can calculate the HU. Now, to know the point of rotation ZR, we have to take the moment. Okay. So, in this way we can do it for uniform distribution case, we can do it for the linear case also. So, for the linear case the distribution will be okay. So, directly I have already given the linear case distribution. So, that will also shift from this side to that side. So, that means for the linear case, so distribution will be, so it will go something like this, then it will be like something like that. Okay. So, that means here this is ZR and this is PL, this is PZ and this is the soil reaction. So, for this particular case, we can get the net reaction and that will give me the HU, and for determine the ZR we have to take the moment. So, and that equations are given. So, based on those equations I am just discuss about the concept that how this simplify approach is used, and then I have not given the equation because I have discussed the concept. So, based on that concept equations are derived and then based on those equations these charts are developed. Okay. So, we can use this chart and then we can get the HU. This is PU. PU bar is basically the average. Okay. Now, for cohesive soil, PU bar which is uniform and that value is given 9 CUD, that is for cohesive soil, okay, which is uniform. And for cohesionless soil, PU is nothing but half into PL, as I mentioned that if your P0 is equal to 0 and PL is equal to that 3 of that sigma V dash Kp, because that is assumed for the cohesionless soil. And similarly, I can write that sigma V dash for L, that will be gamma dash into L, okay, and Kp will be equal to 1 plus sin phi 1 minus sin phi. So, this is linear. So, we will get this value. So, once I will get this value, I will get the HU value, because I have to calculate PU bar. This is small p, this is also small p, this is also small p. So, uniform PU distribution, this is PU distribution. This curve is for uniform, this curve is for linear. So, distribution 0 at the surface, 2 at the tip. So, that means the distribution is something like this. So, that means this is PL at z equal to L and this is 0 at z equal to 0. So, this is the distribution. So, pu bar will be half PL by half into PL. So, PL I will get by using these equation, and then I will, and then once I get the E by L value, then for different cases whether uniform or the linear, I will get HU PU DL. D I know, L I know, PU I will get from these equations. So, I will get the HU, which is simple. So, let us see which approach is giving a better result, or the result which we can use for our design. So, this is actually HU. So, the problem, that example problem that I have chosen, that H steel pile, it is a H section steel pile of following properties, and the length of 20 meter is embedded in a granular soil. Two cases, that means this H section pile is embedded in a granular soil and in a clayey soil, and yield stress of the pile is 340 meganewton F square, that is the yield stress. So, for the every material, for the every H section pile, this yield stress is given. Okay. So, this yield stress is known. Water table is 2 meter below the ground surface, unit weight of the soil above and below water table is 18 kilonewton per meter cube and 20 kilonewton per meter cube. So, for the case A, friction angle is 40 degree and cohesion is 0. Case B, friction angle is 0, cohesion is 100 kPa, eccentricity is 0, determine the HU. Okay. So, for this H section, the section which is given, so I am giving the details of that section. So, it is a steel pile with H section, yes, this is the H section, and this is the y axis, and this is the x axis. Okay. Now, there are different terminology. So, this is the D1, which is the depth of this section, and this is the D2, which is the width of this section. So, this D1 and D2, these values are available depending upon which section you are using. Okay. So, for this particular section, D1 value is equal to 246 millimeter and D2 value is equal to 256 millimeter. Flange width is also given. So, this is the width. So, that is 10.6 millimeter. This width is also given. So, 10.6 millimeter. So, all the values are given for a particular section. Now, this moment of inertia of this section for the x axis, that is also given 87.5 into 10 to the power minus 6 meter to the power 4. So, this is also given. So, all the values that I have written are all given. Okay. Now, the size of this section, your equivalent size of this section, that is also given, and that is 250 millimeter. Now, weight is also given, and weight is 0.608 kilonewton per meter. Okay. So, these all values are given. Now, we have to determine the ultimate or HU, ultimate lateral load this pile can take. So, this is the section and these are the details of this section, and in the question the soil properties are given. So, this side all the values are given. Now, we have to calculate the values that we are asked to determine. So, that is HU. Now, before I calculate the HU, so we should know what is the yield moment, because that if it is a long pile or short pile, based on that you have to use the yield moment. So, where the if the size is given 250 millimeter, So, that means diameter we will take as a 250 millimeter, because size means is equivalent width or the diameter, that we are taking the 250, and L is given here 20 meter. 20 meters. So, L by D is more than 20, even it is how much? 20 divided by 0.25. So, this will be around 80. This is 4, so 80. Definitely it will be a long pile. Okay, less than or equal to 20, and if it is close to 20 or 30 or something, then also we can consider intermediate pile, but this is 80 means definitely it will be a long pile. So, this is a long pile. Okay. So, we have to calculate the yield moment, because as I mentioned during my derivation also, the long pile primarily the ultimate load carrying capacity depends on the yield moment of the pile. So, that yield moment we have to determine. So, we have written all the known values. So, next class I will from these known values I will determine the yield moment, because it is a long pile, and based on that yield moment I will determine what will be the value of HU for different cases, granular soil as well as the clay soil, and I will use both the approaches, Brom's theory as well as the simplified approach. Thank you.